All right, nerds and nerdettes, let's get started. Okay. We did this yesterday, but I want to go over it in case you weren't here or if you needed more help. So this is our lab answers that we're going to be working on. I'm going to be demoing out this one, and you guys are going to be doing one very similar, except we're going to switch sodium carbonate to sodium bicarbonate. Okay. So step one, we got to look these things up and write down our balanced formula. Without that, we can't do a thing. Okay. So sodium. Look up your charge, back your periodic table, +1. Look up your charge to carbonate. Look up your charge to hydrochloric acid, and over here as well. So for carbonate, -2. Make your line for balancing later. Sodium is Na, carbonate is CO3. One of these, two of these. We need 2 here. We're going to add hydrochloric acid, HCl. We're going to produce sodium chloride. And we're also going to make CO2, carbon dioxide, and water. Okay. Now we need to balance it. Go ahead. Here's your line down the middle. Make sure everything on the left is also on the right. Balance that equation. And what we should get, 2 sodiums, 2 sodiums, 2 chlorines as well, 2 chlorines, 1 carbon, 1 carbon, 3 oxygens, 1, 2, 3 oxygens, 2 hydrogens, 2 hydrogens. We are now balanced. Okay? So we're going to use some sodium carbonate. That's this guy here. Okay? We want to measure out 0.5 grams of it. Okay? So we're going to write that down. We want 0.5 grams of this stuff. So we need to weigh that out. Okay, now, first thing I'm doing is I have my clean beaker. Okay, fairly clean. When I place this on here, it is telling me that we weigh, you guys can see that, 29.25 grams. I'm going to write that down really quick. 29.25 grams is my beaker. Okay? All I'm going to do now is I'm going to zero that. It's now going to erase the weight of my beaker. And now I'm going to use sodium bicarbonate. And like I said, we want 0.5. And we need a little bit more. Keep going. We're very close. And there we go. Okay, we now have 0.5 grams of sodium carbonate. Okay, the whole point in this lab is we want to figure out how much salt are we going to produce. Question mark over here. Okay, now as you can see, it's fluctuating around. That's just, even like air currents will make that number moving down. That's how sensitive these scales are. Okay, so what we need to do here now, we have 0.5 grams. These are not equivalent to grams. Okay, up here in our balanced equation, these are equivalent to moles. So what we need to do is take this number and change it into moles. And how we do that is we divide it by the molar mass. Okay? So what we need is the molar mass of this. On your periodic table, we need to look up the masses of sodium and multiply it by 2. We're then going to add 1 carbon to it and also 3 oxygens. Okay, so use your mass number to multiply that out Go ahead and do that now. Okay, so what we should have gotten, we do that 22.99 times 2 plus our 12.01 and plus 16 times 3, and we got 105.99 grams. Okay, so now we have 0.5 grams. And what we're going to do, we're going to figure out how many moles that is. Okay, so we need, for every 1 mole of sodium carbonate, okay, we should have 105.99 grams. And let's just make that 106 for now. 106 grams. Grams cancels out, and we're going to be left with moles. This will tell us how many moles we're starting with over here. Think of this like taking a recipe, and we're changing the amounts we're starting with. Okay. So now that we have that on there, okay, we're going to add some hydrochloric acid. Now, I'm going to do this above the scale. Do not do it above the scale. Okay? You guys are going to do it at your lab table. And then what we should see happen is we should basically get some CO2 bubbles. We should have some water produced and also some salt produced, some sodium chloride. Okay? So, sodium, so right here, hydrochloric acid, HCl. And right away we're getting bubbles. Okay? I'm going to give it 2 good squirts. I should not need more than 10 milliliters. Okay? And we have lots of bubbles. Stir that around. Make sure our reaction is all good. Give 1 more. Okay, lots of mixing, and it looks like our reaction is complete. Just double check. Okay, so it looks like we are completely reacted. So now let's switch cameras really quick. Okay, so now we want to heat this up. Okay, so the reason we're going to heat it up is because we want to know the mass of just the salt, which means we have to get rid of all that water we just made. Okay, so I need to find my lighter. We're going to start our Bunsen burner. And there we go. Okay, we're going to let that burn off. Okay, and the idea is we want to get rid of, we're going to get this up to a boil. And we want to get rid of all of that water. That way we're left with just the salt. Okay? So we're going to let that go while we go back to our notes. Okay, so back to here. Okay, so right now, I want you guys to go ahead, take a crack at this problem here. Type that in your calculator and see what you get. .5 divided by our molar mass, and we should get 4.716 times 10 to the negative third. Okay. Now we're going to take that out of scientific notation. We have that many moles of sodium carbonate. So this is a small number because our coefficient is -3. I'm going to zoom in just so you can see that a little bit better. Okay? So now let's write that out, the number it actually is. So if we take this out of scientific notation, 0.00472. 1, 2, 3. It's that many moles of sodium bicarbonate. Okay? So now, this is how many moles we have on our left-hand side. So if we go back to our equation, okay, we have this many. Okay? right here. So now, for every one of these, we're going to make 2 of these. So for example, if we actually had a 5 here, we'd actually end up making 10 of these. If we had 3 here, we'd end up making 6 of these. Okay? If we have 5 here, we'll also only be making 5 CO2 because it's a 1-to-1 ratio. If we had 10 here, we'd be making 20 amounts of salt. Okay, so what we want to do basically, every single time we're multiplying by 2 to get this number. So we're starting with a difficult number. We have this many moles of sodium carbonate, and we're going to make twice as much salt. So all we simply have to do is take this number and multiply by 2. Okay, so this 2 here, because we have a 1-to-2 ratio, we're going to take this number and multiply by 2. Okay, and what we basically are then getting, let's see, take 0.00472 and multiply by 2. And we're getting that. 9.44 times 10 to the negative third. So we now have 9.44 times 10 to the negative third. Okay, this is our new product, our moles of salt, NaCl. Okay, we're going to write that out. 0.00944 moles of salt. Okay, so now once again, this is how many moles we're making. Okay, now I can't use my scale to measure in moles though, so we're going to now take this number, okay, and we need to multiply by the molar mass to get back into grams. Okay, so go ahead, 0.00944 moles. I'm going to set this problem up. Every 1 mole of sodium chloride weighs how much? Look up your molar mass of sodium, 1 sodium, and 1 chlorine, and add them up. Okay. So we then have 22.99, and we're adding 35.45. And then we get 58.44 grams. Okay. So now while we're doing this, cross these out. This is multiplication because they're both on top. Multiply out these two numbers. 0.00944 times 58.44. And we should get, at the end product, what we should get is 0.55 grams of just salt. Okay, so as soon as this is done boiling off, we've gotten rid of all of our, all of our water. This is how much salt should be left in there. Okay, so right now ours is still boiling off, so I'm going to make up a number. The one I got in one of my classes today, after we waited for it to cool off and we measured it, we got 0.48 grams. This is what we measured out of sodium chloride. Okay, so we were close, but not exact. Okay, so this number that we calculated out, this is called your experimental yield. And the number here we got was your theoretical yield. Oh, you know what? I just said those backwards. No, mixed that up. This one, the one we calculated out, is your theoretical, T. This one is your E, your experimental yield. Experimental, that's what we got when we actually did it. Theoretical is the one we calculated. It's the one we used math to figure out. Okay? So our last equation on here, to figure out your percent yield, okay, equals experimental over theoretical times it by 100. Okay, so let's do that now. Take 0.48, divide it by 0.55, and times 100. Let's see what we get. Okay, and we get 87.3%. Okay, 87. Whoopsie. 87.3%. So that's pretty good. That's not too bad. We're normally trying to get up to at least 95% accuracy, but for what we're doing in this chem class, we're not doing all that bad. Okay, so I'll show you one of the ones from earlier. Here's the one of the ones from earlier. So here's all the salt that we obtained. So when we measured that out, what that weighed out to was 0.48 grams. We were hoping to get 0.55 grams, but there's a number of reasons why we might not get all of it. Some of it might have boiled off. We might not have used the right concentration of hydrochloric acid. We might not just have obtained it all. We actually have soot on the bottom of this that will throw off our answer. So there's lots of reasons why we might not be 100% right. Okay, that's our lab. We're all set.